Hello guys, my name is Divyaprakash and I'm a data scientist with over 1.5 years of experience. I'm going to take part in a challenge where I'm going to work on a project and I'm going to document each and everything that I'm going to do as part of that particular project. So it is going to be a series of video where I'd be doing that project step by step until I reach the final destination. So that's going to be the agenda for the set of videos that are going to come in this particular channel for the next couple of days or a next set of days. I'm not very sure how long this is going to be. So yeah, that's going to be the agenda for it. So coming to the problem that I have, so this is the particular dataset that I have. So this is an hull performance dataset, or like hull is basically ship. So this is a ship performance dataset which contains engine specific readings for each and every hour of the voyage of the ship. So it's been recorded for each and every hour throughout the voyage. So I have engine specific features like speed through water, fuel consumption, the torque of the engine, the absolute speed through ground, and the geographical location, longitude and latitude, as you can see. So these are some of the set of the features that I have, and the problem statement is to analyze the performance of the ship. So this is a very vague and abstract level of problem statement, but if you go into details, like is to develop a system which can forecast some of the KPIs through time, because the data set that we have is a time series data set. So somehow, like, if we can forecast certain KPIs which are related to the engine to do some kind of predictions, like if we have a business problem, like if the people in the ship or in the middle of a voyage and they know, like in how far they need to go, so they would be having some amount of fuel in their bank, and they kind of need to estimate whether the available fuel is what is the estimated fuel consumption for the rest of the voyage. So this can be one kind of a problem. Or like we can kind of quantify the performance of the ship over time, because this end of the day it is a device. So all these devices, as if we use a common sense, there would be some kind of trend or decay in terms of its performance over time. Either it can be a battery, or it can be a simple electronic device, or a ship's engine in this particular case. So if we are able to somehow quantify the change in performance of the ship, that would be as well another kind of a problem that we are going to solve. So these are some of the set of things that we are going to do in this particular project. So basically we're going to analyze the performance of the ship over time. So that's going to be the agenda, and this is the data set that we have. So let's now get started with our coding part in our Google Colab. So this is the setup I have right now. I have imported the dataset here. So I'm gonna import some packages for now. So I'm gonna import pandas, and I need numpy as well. Import numpy np, and I need matplot. I need pyplot splt, and import seaborn ssb. SNS or SV, anything is fine. So these are the packages I'm gonna import for today. And the thing is, like, I'm not going to solve the entire problem here. As I mentioned, like, I'll be focusing on specific issues for each day. For now, to get started, let's just understand how the dataset is and do some visualization to check, like, how the data is actually structured. So we looked at the data in the Excel sheet, and we looked some of the features and the intervals at which the data is actually segregated. But let's dig a bit deeper and see how it has actually been there. So let us first load the data. So data is equal to pd dot read, and this is an Excel file, so it's been Excel, and the address series dot excel sx. Yeah, so this is the data that we have. We just load it, and let us just see the first 5 rows of the dataset. So it has a lot of columns, at least like around 30,000 to 40,000. So that's the reason why it's taking a bit amount of time to actually load the dataset. So it's now been loaded. So these are the features and kind of data that we have right now. And I don't like, no, it's pretty good since it has some kind of units with its name, but it's kind of annoying to have them right now. So I'm just gonna change the name of the columns for now. Have this snippet for it. So yeah, this is the column I have, and I'm just gonna rename the columns. Columns is equal to cleaned column names. I'm just renaming them with simpler names. So once that is done, I'm printing the data again. So this is the kind of dataset I have, and as I mentioned earlier, it was for each and every hour it's been recorded. But let us first check that whether it is actually recorded for each and every hour. For that, like what I'm gonna do is, we have this particular dataset. The approach is pretty simple. First, I'm gonna find the earliest period and the latest period. So the earliest record, so the record which has the most earliest timestamp and the record which has the most latest timestamp. I'm gonna check like whether each and every hour present between those two timestamps is actually there in this particular dataset. So the approach is pretty simple. What I'm gonna do is uh, create a new data frame, create a new data frame, create a new data frame with that particular range between the earliest period and the latest period in the frequency of hours, and then create a data frame using that particular series, and I'm going to merge it with this existing data. I'm going to do specifically left join with this, so that the left side database is the period range and the right side is the actual data set that we have, so that when we do left joining, we'll be having null values for the dates that are present in our left table, which is nothing but the date range table, and the which is not present in the actual dataset. So if we can find those null values, then we can sort that to find what are the missing hours which is not present in the dataset, which is in the date range. I think so I'm clear. It will be more clearer when we actually work on it. So first is to create a new data frame with a range between earliest recorded period and latest recorded period. So this is what we're going to achieve. So the earliest period is nothing but data of the column name is daytime. So this is the column name and the minimum of that particular thing. So daytime dot min. So it's going to be that, and this is basically going to be the max of it. So that's the latest timestamp. So we are going to create a date range column, which is nothing but pd dot date range, I believe, and the start and end time we need to specify. So start is basically going to be the earliest period. Start is going to be earliest period, and the end is going to be the this is latest period, sorry. So latest, so the idea is to get the earliest period and the latest period. So latest period, and before doing that, we need to make sure that this particular data type is actually datetime data type. That I forgot to do it. Let's just first check the data types of this particular data frame. So data.d types will give that. So since datetime column is in daytime, so we can go with this approach. But if it is not the case, if it is an object or if it is in string format, first we need to convert that into daytime and then proceed with this. But for now, this is kind of okay to do. So we are creating a new data frame. So for that, we are getting the minimum and maximum date, and then we are creating a date range. So this is going to be a pandas series. So we need to convert this into a pandas data frame. So I'm gonna do date range df is equal to pd dot data frame, and the columns names, it should be in a dictionary format with the column name. So I'm gonna put the same name so that it will be easier to join it. So it's going to be date time. The column name will go as a dictionary key value pair. The key will be the column name, and the value will be the pandas data series that we have created. So if we do this and we can just have a look at the data frame that we have created. So this will have datetime as a single column data frame with the datetime, and this is the data set that we have. So this, if you look at the number of sorry, like this is actually for I forgot to specify the period. So this is actually creating a date range for each and every dates between these particular time frames. But since the data frame is has a frequency of hour, I need to specify that. I forgot to do it. Yeah, we got the desired result after changing the frequency to H, and we got our things ready. So if you can see that it's 48,000 rows here between the start and end time. So we would expect the same amount of things there in the original dataset as well. Let us just check how many rows are actually missing. So I'm gonna compute len of date range df, the df that we have now created, minus the length of the actual data. So we see that around 9,000 rows, meaning 9,000 hours are missing between the between somewhere between these kind of data frames. So it is recorded between first one is 2018 July 19th 12, and the second one is 2018 July 19th 1. Somewhere it is continuous, the first five, but somewhere in the data set we have some kind of missing values. So that the count is 9,058. So we have identified that now. What we're going to do is, as I mentioned earlier, we're going to merge it so that we can have null values for the within the dataset itself, so that it will be easier for our manipulation. So left joining date range with original data frame. So that's what we're going to do. So merged data or data extended will be equal to pd dot merge, and the left data is going to be the date range df, the one that we have created with the date ranges, a single column data frame. And the second is going to be the right table is going to be the original data set, and on is going to be the date time column. And how we are going to do, it's going to be a left join, so it's a left, and yeah, paka. So we have the extended data, so data dot extended. So if I get the null value counts, it should be equal to 9,058. Let me just check that. So I'm getting 9,058 for each and every column except the datetime column, because that's the one we are actually merging with. So we got this. Now let us create a flag data extended to specify one for missing and one for missing date time and 0 for not missing. So we can't do that with datetime because datetime is the column that has no null values. So we need to check for rest of the columns. So we can define a list like columns to check. So that will be a simple list comprehension. So for column in data extended dot columns. So data extended dot columns will give a list of columns. So we are gonna loop through that and check if column not equal to datetime. Yeah, so this is the idea. So this will now contain all the columns except the datetime column. So if we can have a look at this, let us just, yeah. So column to check is all the list of all columns except the datetime column. So we'll have that for now. And what we are going to do is data extended, and we are going to create a flag which is going to equal to a 1 if it is missing and 0 if it is not missing. So what I'm going to do is I'm going to check that condition. So data extended of columns to check and is null dot, I think so it should be since any column within this, if it is null, we are gonna count that as a missing column. So dot any, and the axis will be 1 to specify that we need to check it row by row. And so this will give the value as true or false. Like, if you just take this thing and execute it in a different cell, so it will give a true or false value. If it is a false, it means that it is not having any kind of null value, and if it is a true, it says that like it has a null value. So if we can interpret this like it is false means we need to have 0, and if it is a true we need to have 1. So if a simple type conversion of as type int will give zeros and ones for the false and true values. So that's what we're going to do there. So that's the actual need as well. So we'll be putting that here. So this data extended flag, sorry, if we now have a look at the data extended column, so we'll be having a flag which will say it is a 1 or 0. If we can have a look at it, so data extended, we'll just filter out the flag where it is 1 actually. So if we do this, all the values are null like when we do that. So basically, like if we do columns to check for this and check for null values, it should be null for each and every values. Is null dot sum. Yeah, so this is the thing actually we want. If we just have created a flag to actually flag them, so we have done that, and we have done this as well. Now the idea is basically to kind of check like which part of the area these missing values are present. Like either these are a chunk of values, or are they going to be very minor values, and or if it is in a medium between those things. The idea is actually to check where these missing rows are present. Say for example, if we have 20 to 30 days where the value is missing, this means that the ship is not operated for that particular area, it has been stopped. Or just we have 1 or 2 rows which is missing, which means that a simple error in the device that is actually recording these values. Or in some cases it can have a larger gap to 1 year or 2 year, basically a COVID breakdown where they have completely stopped operating the ships. So if we can kind of segregate them into how much the gaps between these missing values, it will give us good intuition to do some kind of to get more knowledge on how the dataset is actually constructed. So that is the reason why we need to somehow we need to know how these values are separated. So for that, what we can do is we can first bucket them into separate buckets where we can segregate the first the values which is present as one bucket, and the values which is not present at the second bucket, and then again the values which are present. So if we can sort the data and then assign buckets for each of them, so we can have a set of buckets which will say it is present or not. So we can segregate them into groups. So we should not group them into flags, but we need to have the continuous values of zeros and ones with respect to the flags as buckets. To kind of have a better clarity on how the bucketing works, I'll just have a look at the Excel sheet I have. So if this is the flag column we have, it has zeros and ones. The bucket column should look something like this, where the first zeros are considered as the first bucket, and the second set of ones is considered as the second bucket, and the third it's again zeros, it's third bucket, and fourth ones it's ones again, so again it is a fourth bucket. So we are segregating the consecutive occurrences of zeros and ones as separate buckets. So that's the basic idea. Let's now see how we can actually implement it and get the buckets column. So coming back to our code, so the existing or the current data frame that we have, let's just have a look at it. Dot head of maybe 3 columns. So okay, yeah, so this is the thing that we have right now, And what we need is to have a bucket column for this, as I mentioned earlier. So what I'm gonna do is first, like if in this thing, in this particular data frame for the flag column, if I kind of need to check for the next consecutive value, so what I need to do is I need to use the shift operator. So if I put data extended of flags dot shift of, and if we specify +1, we'll be getting the preceding values, and if we put a -1, we'll be getting the leading values. Since we are more interested on getting the preceding values, let's go for the -1 tag for now, sorry, +1 tag for now. So this will, for the first one it is not available because for this there is no lagging value, but for the second consecutive thing, so this will be the value for the second row, and this will be the value for the third row. For each row, the preceding value of flag will be in this particular extension column. So what we are actually going to do is, what I'm going to do is check for values where the preceding value is not equal to the current value. So I'm going to check for such columns. So this will actually say at which point the bucket is actually changing. So what I'm going to do is, as I mentioned earlier, so data extended, and the value of this particular column is going to be bucket, and then it's going to be equal to data of flag. So what I'm going to check is, I'm going to check whether data of flag is not equal to data extended of flag of shift of 1. So I'm just checking with the lagged value, and if this particular thing is true, what I'm going to do is, like, I'm just going to do a cumulative sum of this particular thing, this particular entity. So if it is true, it's going to be 1, and if it is going to be false, it's going to be 0. So that's what we discussed. So this particular particular snippet will actually give us the buckets. Now we have the buckets. What we can now do is, like, kind of, we'll group the dataset that we have right now into this buckets, the extended dataset, with the start and end time, along with the flag, like whether it is missing or it is actually present. So this will give a period of data, like, from which start point and which end point, whether the value is actually present or not. And then we can construct a broken bar plot, which is actually used to visualize these kinds of stuffs. Now if you go to the official documentation, as you can see in the screen, so the resulting bar plot will look something like this. So here this blue color part might represent the data is actually present, and the gaps, white colors, would represent the missing data. So we are attempting to build something like this to to visualize the data points which are missing and which are present, and at which point they are actually done. So for that, we need to group them by buckets with the start date and end date, along with the corresponding flags. So we'll do that first. So grouped df, we can call it like this. Group df is equal to, we're gonna group by this particular data frame. We're gonna group by, and the column we're gonna group by is bucket. And how we are gonna group it? So we are gonna first aggregate it. We're gonna do multiple aggregation. So first, for the minimum date, so start date, we can call it a start time, should be the most appropriate word, start time. And the column that we are going to aggregate is the date time. So date time is the column, and the type of aggregation is minimum. So minimum gives the starting date for each bucket, and then the end time is going to be date time of max. So this gives the maximum date time, and the flag as well. So flag is going to be flag of minimum. So like any value should be fine, because it's going to be the same value for the entire bucket. So the flag can be min or max, doesn't matter. So this is what we get, and I'm just gonna reset the index so that we get the group df. So grouped df. Okay, I just need to rerun this, just give me a second. Okay, I just lost connection, just give me a minute. Yeah, so this should be running when it is ready. uh, I'm just running, I'm just waiting for the output. This one is grouped df. Okay, I got a typo here. So yeah, so this is the kind of data frame that we have. And for broken bar plot, what they are expecting is a start time and the duration. So we'll just first compute the duration for the between the start time and end time for this particular data frame that we have. So grouped df of duration. So that will be equal to grouped df of n time minus grouped df of, this should be minus start time. So yeah, I'm getting the grouped duration here. So let me just have a look at this grouped df. Yeah, I get something like this with the durations between for each of these buckets. Now what I'm going to do is I'm going to loop through this particular data frame. I'm going to plot the bar plot. So broken bar plot. So plotting the broken bar plot. And so first I'll plt.figure will give a good resolution to our plot. So it's going to be a very small horizontal bar plot. So width, it should be have good width, so 20, and the height can be 3 for now. And since this broken bar is available in matplotlib, so plt dot, I think so it's broken, what is that, broken bar h. So broken bar h, and what they want is, I need to do this for the entire data frame. So I'll just loop it. So for row in broken grouped df dot iter rows. Actually this gives index and row. So index can be this and row will be this. So this will give the each row of this particular data frame, and we can access the columns by putting the index of the name of the column names. So broken bar h, and the argument for this is going to be a list of a tuple. So, and that tuple is going to be the start time and the duration. So row of start time and row of duration. So this will be the specification of the width of the bar. So from a start time to which point it should actually be there. And the second argument is again a tuple which specify the height and starting index of the y. So we can start from the origin itself and then have a width of 1 unit. So that will be this. And for the colors, they have an argument called face colors, I believe. I just need to check the documentation. It's not available here, but I think so it is face colors. Let us check. And I need to have a column variable for it. So let us have a variable we can have red if row of flag is equal to 0, else green. So sorry, we'll have this as green and this is red, so that we'll be having the if the flag is 1, we'll be having a red color, and if it is 0, we'll be having a green color. Specifically, if it is a green color, it is said that the data is present, and if it is a red color, the data is missing. So that is the idea here. So we have the color. I'm gonna put color, and like I think so I made a mistake here. It should be this one. Yeah. So this is a list of tuple, and I have this, and face color is equal to color. I think so. Things are fine. I just add some labels. Plt dot x label is going to be time, and plt dot y label, because it's basically it's going to be the we don't need a y label here actually, because there is no y axis here. So plt dot title can be uh, continuity in the time series data, and yeah, so this should work. This is what we're expecting. Yeah, as you can see, like the red stripes basically represents the points or the time Harley times where the data is actually missing. If you remember at the start of the video, we kind of discussed on to analyze whether the data set is continuous, and if so, like at which points the data is actually missing, and we kind of wanted to visualize whether it is a very small fragments or it is a chunk of values. As you can see, like at places like this place and this place, it's very tiny chunks, but at some places it is a very huge gap. The gap is pretty large. So yeah, we need to analyze it more, because the axis, the scale is not specifically mentioned here, so we can't come into any kind of conclusion right away. But we can get an idea, like there is differences in the areas where the differences in the gaps between the time. So that is the basic understanding from this particular visualization and this particular video as well. So I just wanted to start with something, and I made this particular video. I hope you guys enjoyed it, and we'll continue the rest in the upcoming videos. Thank you.